Bismillah ar-Rahman ar-Rahim. Good morning, everybody. Inshallah, today I'll answer with you the questions in page 187. These questions related to chapter 17, page 187. I explained chapter 17 and chapter 18, and I wrote for some students that I'll make a separate video to answer the questions for both chapters. So let's remember together what we have in chapter 17. What we have in chapter 17. In this chapter, we talked about acid, bases, and salt preparation. Acid, bases, and salt preparation. Okay, I said to you, what does it mean by salt? What are the important things I want from you in this chapter? I'll repeat again. And inshallah, I'll make revision for chapter 14, 16, all the chapters. Okay? What does it mean by salts? As we said, salt is something produced from neutralization reaction between acid and base. Between acid and base. When the hydrogen of an acid is replaced by metal, it will produce also salt. So salt is a product from neutralization reaction between acid and base, and also salt comes from when the hydrogen of the acid replaced by a metal. Okay, so I want the definition of salt in page 173. And also I said to you, in case of acids, all the acids contain hydrogen ions. Start with H in the formula. So the first is hydrochloric acid, nitric acid, sulfuric acid, as you see here, like this. And this is an organic acid, ethanoic acid, and phosphoric acid. Okay, as you see here, hydrochloric acid is hydrogen with chlorine. Nitric acid, hydrogen with nitrate group. Sulfuric acid, hydrogen with sulfate group. And ethanoic acid, also hydrogen and ethane. And we have here phosphoric acid, phosphate group, and the hydrogen. Okay, so here these are the acids, and all acids contain hydrogen ions. Okay, we said that the chloride is the name of the salt for the parent acid, hydrochloric acid, and nitrate is the name of the salt for nitric acid. As you see, this table 17.1 is important to know the name of salt comes from the parent acid, like this. Okay, and also we said that salt is formed when hydrogen, this is the table of acid replaced with also ammonia. Okay, reactions of acid. We said that the acid can react with metal, produce salt and hydrogen, like magnesium and sulfuric acid, like zinc and sulfuric acid, any equation like this. Okay, I said to you make attention for these equations because I want from you to know that reaction between metal and acid, whatever the acid, the reactions will be the same. يعني magnesium plus hydrochloric acid, when you work with the equation and make it full ionic equation, and also magnesium with sulfuric acid, magnesium with nitric acid, and so on, magnesium with hydrochloric acid, okay, and remove the spectator ions, you will get the same equation here and there, like this. In case of here, in case of sulfuric acid, what is the final equation? Magnesium plus hydrogen ion produce magnesium ion. You can find it in the salt and the release of hydrogen. And here, in case of magnesium plus hydrochloric acid, When we remove the spectator ions, you will find the same equation, magnesium plus hydrogen ion. Also here, magnesium and hydrogen ion, magnesium and hydrogen ion make the cation, the magnesium cation ions in the salt and release of hydrogen gas. Okay, we said that's a general equation. Metal and acid produce salt and hydrogen, whatever this metal, magnesium, whatever this metal, zinc. But in case of zinc, you will find that the reaction is less reactive than in case of magnesium, according to the order of these metals in the reactivity series, as we said before. We have also base and alkaline. Base and alkaline, I said to you, we have different bases like oxide, metal hydroxide, metal carbonate. All of them, we call them bases like this. And the reaction between the oxide and the acid produce salt and water. The reaction between hydroxide and acid also produce salt and water. Okay, I want from you to know that the base or alkaline contain hydroxide ion. Okay. Also here, I said to you the reaction between acid and the carbonate, of course, produce the salt of acid plus carbon dioxide. Any carbonate in the reactant produce carbon dioxide and water. Okay. I said to you here is important thing, salt properties. Okay, or how we can make preparation for salt. I said to you, memorize these main two ways only. That if the salt is soluble, let's revise first what are soluble and what are insoluble salts. I said to you that all sodium, potassium, and ammonium compounds are soluble. Whatever the sodium, the potassium, the aluminum compound, you can find them soluble. Ammonium chloride, sodium hydroxide, potassium carbonate, so all of them soluble. If you find sodium, potassium, ammonium, so the salt is soluble. When I talk about solubility, I talk about solubility in water, because we have different kinds of solvent, like organic solvent. Okay, and I said to you also that nitrates, all nitrates are soluble. We have most of chloride soluble, with exception. Most of chloride soluble except two chloride like lead chloride and silver chloride. And also I said to you that sulfate, most sulfate are soluble except lead sulfate, barium sulfate, calcium sulfate, like this. Okay, and I said to you most of hydroxide are insoluble except what? Except sodium, potassium, ammonium hydroxide. And most of carbonate are insoluble also except the sodium, potassium, and ammonium. Okay, now we know what are the soluble and insoluble salts. I'll ask you about the ways or methods used to prepare these salts. If the salt is soluble, I ask myself if the salt is soluble. If the answer is no, that's to say the salt is insoluble, I use precipitation method. I said to you, don't forget to complete your answer to say that precipitation method is a reaction between two solutions to produce precipitate. And if the salt is soluble, not soluble, so precipitation. If the salt is soluble, so I'll ask another question. If this salt is sodium, potassium, ammonium or not? If it is not sodium, potassium, ammonium, so you can react either, and take care. We have a question in the end of chapter asked about this. We can use the metal itself if the metal is reactive, but don't use metal like copper with acid. Okay, so you can use the metal itself, you can use the metal oxide, you can use metal hydroxide, you can use metal carbonate to produce this soluble salt. Okay, and if the salt is sodium, potassium, and ammonium, we have what we call titration. Okay? And I said to you, titration is a process. We use it to detect the amount of acid, alkali or alkali acid to neutralize each other. يعني say I explain to you this experiment for titration. I said to you if we have مثلا 25 I think titration in other chapter. Okay, so titration is a process I can use it to detect the suitable amount from each base and acid that can neutralize each other. Okay, here I said to you this experiment is very important, how we can prepare copper sulfate in the lab. Okay, to prepare copper sulfate crystal in the lab, you can add copper oxide and sulfuric acid. Okay, copper oxide and sulfuric acid. The salt will produce this copper sulfate. This copper sulfate is soluble, so we can add excess of the copper oxide and set to you a lot of why questions in this chapter. Why we add excess of copper oxide? Because I want to be sure that all the acid reacts with the copper oxide. Okay, what I'll do with the remaining copper oxide, use filtration to remove the excess. How I can change the copper sulfate into crystal? By gentle heating, and from time to time I'll use this glass bar and put it in the solution, then hang it in the air. If it change into solid, so stop heating, because I want to collect it as crystals. And I said to you, very important to know that the copper sulfate itself is anhydrous copper sulfate, but copper sulfate crystal is copper sulfate with water of crystallization. Like this, a number of water of crystallization, number of water molecules combined with the copper sulfate salt is 5 water molecules. And you have to memorize well that the copper sulfate itself is white powder and the copper sulfate crystal is blue. And we use it to test the presence of water, and we took it in chapter 18. Okay. Also, I want from you, I said the summary for these 2 pages is here. Okay. And what does it mean by acid-base reaction or alkaline reaction? Okay, acid-base reaction. I said nothing. Okay, like this. We have theories in acid and base reaction, like Pronosted theorem. He said that all acids contain hydrogen. I made highlights for what I want. They said before, as a definition of acid, that all acid contain hydrogen ions, all bases contain hydroxide ion. Okay? But here we have another definition for acid and base. I said to you, important. Acid is hydrogen donor and base is hydrogen receptor, because they cannot explain the reaction between ammonia and hydrochloric acid. Reaction between ammonia and hydrochloric acid is an acid-base reaction. But here hydrochloric acid contain hydrogen, it's okay. But ammonia does not contain hydroxide ion. So how I can explain this as an acid-base reaction? They change the definition into that acid, anything produce hydrogen donor, and base hydrogen receptor. Okay, this is according to Pronosted Lowry theorem. Okay, you have to know that H3O1 plus, we call it hydroxonium ion. Important equation, hydroxonium ion, where I can get this hydroxonium ion when the acid dissolve in water. Okay, I said to you acid base reaction very important, and I send a copy from another book to you contain some acid base reaction and not acid base reaction. When I ask about which is acid base reaction, you have to tell me what is the acid, what is the base, like this. Okay, here you have acid base reaction like this. Now let's answer the questions in page 187. What I revised with you, this all important things I want from you to memorize well. Okay, here state which, question 1, state which of the following will react with dilute sulfuric acid. State which of the following will react with dilute sulfuric acid. Of course, copper will not react with dilute sulfuric acid. Why? Because copper is under hydrogen in the reactivity series. So when I prepare, and I said this when I explained this lesson before, I said to you, we can replace copper oxide by using copper when I make the copper sulfate crystals. I said no, it is not suitable because copper will not react with the acid either, cold or warm acid. What about copper oxide? Copper oxide will react with the acid, produce salt, copper sulfate and water. Here copper hydroxide also produce copper sulfate and water. Copper carbonate also produce copper sulfate, water and carbon dioxide. Okay, to write the equations like this: copper oxide plus sulfuric acid produce copper sulfate and water. Copper hydroxide and sulfuric acid produce copper sulfate and water. Copper carbonate and sulfuric acid produce copper sulfate, carbon dioxide and water. Okay, I sent the answer, photo from the answer to you, but I want to revise it with you. Inshallah, next video I'll revise with you chapter 18, and then I'll revise 16 and 14. Okay, here he asked to write equations. This is question 1. In question 2, read the question, please. Read this description of the chemistry of metal A and some of the compound, and then answer the question. He said metal A and the other letters for compounds. Okay, metal A has no reaction with dilute hydrochloric acid. Underline has no reaction. Has no reaction. Which thing has no reaction with the acid? Of course, it will be metal under hydrogen in the reactivity series. Maybe copper, silver, gold. Let's complete. So underline please, no reaction with dilute hydrochloric acid or dilute sulfuric acid. It forms a black oxide. Black oxide. Do you remember? Oh, now I start to remember it. I said to you, any color in chemistry is very important question. Do you remember when I want to detect the amount of oxygen in the air, and we started to heat the copper with amount of air in a syringe? Do you remember this? And I asked about this in the midterm exam, how we can detect the amount of oxygen in the air. I asked about the iron, I know, but also we took how we can detect the amount of oxygen by using copper. And when we heat the copper, it will change into black. So now I can say that the metal is copper and the oxide is copper oxide, because he said to me it does not react with both dilute hydrochloric and sulfuric. So I think about copper, silver and gold, and he said to me it has an oxide, and this oxide is black. Which was black oxide? El copper oxide. So letter A is metal, copper, and letter B is black oxide. Okay. Letter B, black oxide, which reacts with hot dilute sulfuric acid to give blue solution. So here, nice, very nice. When I react, blue solution C, when I react the metal oxide, because the metal itself does not react with both acids, when I react this copper oxide with sulfuric acid, it will produce blue solution. Blue solution of what? I have sulfuric acid and the copper oxide, so the blue solution is copper sulfate. So C is copper sulfate. Metal A, which is copper, also forms a green compound, So this green compound is carbonate, metal carbonate. And I said to you, I think that you saw it in the lab last year in grade 7. Okay. Here, letter D, which reacts with dilute nitric acid. So he talk here about D, which is green compound. So it is copper carbonate. Reacts with dilute nitric acid to give a colorless gas. Of course, the carbonate with any acid produce a colorless gas, because this gas will be what? Carbon dioxide. Yes, excellent. And colorless gas E. And another blue solution. Yes, I have copper carbonate and nitric acid, so it will give me copper nitrate. Okay. So here, what are these letters? A is copper, B is copper oxide, C is copper sulfate, D is copper carbonate, which is green in color, E is colorless gas, which is carbon dioxide, and F is also blue salt, which is copper nitrate. Okay, here, as you see, this is the first letter A, and he said write equation for the reaction between dilute sulfuric acid and B. We said that B is copper oxide. I said to you, very important, and I said this experiment is very important also. Okay, here B, copper oxide plus sulfuric acid produce copper sulfate and water, and he said here D and the dilute nitric acid. What we said about D, so I'll write copper carbonate, CuCO3, plus nitric acid, HNO3. To balance it, it will be 2HNO3. Produce copper nitrate, water, and carbon dioxide, like this. Okay, this question. Now, I want question number 4, important. And I have to ask about this. He asked to classify or to organize the following compounds. I know that I leave this. I want number 4, so I solved 1, 2, now 4. Okay, and what I said important, and I said to you make highlights on it in this chapter. So here, organize the following compounds into soluble and insoluble salts. What about sodium chloride? Sodium chloride is soluble. Why? Because we have sodium. We said sodium, potassium, ammonium, soluble. Okay, and here we have lead sulfate. Lead sulfate is insoluble. Zinc nitrate. Nitrate is soluble because nitrate, we said all nitrate are soluble. Calcium carbonate. Carbonate are insoluble except sodium, potassium, ammonium carbonate. Iron sulfate. Of course, iron sulfate is soluble because we said most of sulfate soluble except lead sulfate, barium sulfate, and calcium sulfate. Lead chloride, insoluble. Why insoluble? Because we said most of chloride are soluble except lead and silver. Potassium nitrate, potassium, so directly soluble. Copper carbonate, carbonate, so directly insoluble. Here, silver chloride, silver from the exception. Most of chloride are soluble except silver and lead. Aluminum nitrate, nitrate so soluble directly. Barium sulfate insoluble because most of sulfate are soluble except, this is from the exception, lead, calcium, barium. Ammonium chloride, ammonium so directly soluble because sodium, potassium, ammonium are soluble. Here magnesium nitrate, nitrate so soluble. Calcium sulfate from the exception, most of sulfate are soluble except the calcium, barium and lead sulfate. Sodium phosphate, sodium so it is soluble, sodium. And nickel carbonate, directly carbonate are insoluble because all carbonate are insoluble except sodium, potassium and ammonium. Okay, here chromium hydroxide, hydroxide so directly insoluble. Potassium dichromate, of course soluble because potassium. Okay, this question is important, I prefer it. And here describe how we can make copper sulfate crystal. I'll ask in the form of the equation, the color of the crystal, the color of the salt. We can replace the copper oxide by using copper or not. All things I explained to you in this experiment. So this experiment is important. Okay, you can study it from page. Let's return again. Here, page 179. Why we add excess, why we can't use copper, what is the equation, how I can deal with the excess by filtration, how I can make it crystal, what is the sample of formula, of crystal, what is the color of crystal, and I can add a question with it from chapter 18, how I can test presence of water. It will change anhydrous without water copper sulfate into hydrate copper sulfate crystal. Okay, I want from you question number 9. About question number 7. I want to make silver chloride. Silver is cation, positive, and chlorine is anion, negative. You know this now. So I can use any solution contain silver and another thing contain chloride because I can't use silver itself with hydrochloric acid. Calcium carbonate, we can use calcium itself because calcium is reactive with carbonic acid. Okay, or two solutions, one contain calcium and one contain carbonate, make displacement reaction. I sent the answer for you. Okay, but it's important to me to know this. Question number 9. In case of question number 9, he asked us how we can make these salts. I have zinc sulfate, so it is zinc above hydrogen in the reactivity series, soluble because it's a sulfate. It is not from the exception of sulfate. Sulfate does not do not soluble like قلنا الليد والكبر والباريوم الليد والكالسيوم والbarium sulfate. Okay, so here I can add zinc and sulfuric acid to make zinc sulfate, zinc oxide and sulfuric acid to make zinc sulfate, zinc hydroxide and sulfuric acid, zinc carbonate to make plus sulfuric acid, like this, because zinc sulfate is one of the soluble salts, so we can add excess of metal, but must be active metal, or metal oxide, or metal hydroxide, or carbonate with the acid. I want to make barium sulfate. Barium sulfate also is an insoluble salt, so I have to use solution contain barium. Okay, solution contain barium, salt and sulfuric acid. Potassium nitrate, I can use nitric acid and potassium itself. Okay, and potassium oxide and potassium hydroxide and potassium carbonate. Okay, and here I want to make lead chromate. Lead chromate, here I can use any salt to contain lead and any salt to contain chromate. Okay, but as I said to you, it's important to me to know the ways used to make salts like this. Okay, and here All these reactions are acid-base reaction. Where is the acid? Which contain H3O hydroxonium or contain H. So as you see here, all these here, it's act as base and act as acid. Here magnesium oxide base, here sulfuric acid is acid. Here the acid and the ammonia is base. Sulfuric acid, acid, and water act as base here. Take care from this equation. Ammonia is base and hydrochloric acid. This is according to Bronsted definition, which is acid is hydrogen donor and base is hydrogen receptor. Okay, this is acid, ethanoic acid, and ammonia act as base. Plus the equations I sent to you as a photo. We have in this photo some reactions, not acid-base reaction. Okay, this is a revision for chapter 17. By this way, I finish revision of this chapter. Inshallah, next video I'll revise chapter 18. Thank you. Best wishes.